Hello guys, this is Amar Hatti, your CAD/CAM teacher. I welcome you all to this new video lecture on your fourth unit, that is computer aided manufacturing. Okay, so in last video lecture we started your fourth unit computer aided manufacturing, and we had come to know what is your syllabus, then introduction to computer aided manufacturing, what are NC machine tools, what are different elements of your numerically controlled machine tools, classification of the same. We had that. According to type of the motion, we have some different types of NC machines, continuous path control systems. According to programming methods, we have some classifications of the NC machines, and also we had what are the different types of CNC machines and how they are classified based on different consequences. Okay. So in today's video lecture, we are going to start your part programming. That is the most important part of your fourth unit. Okay. So I already said you what is part programming. So it is, in a simple sense, it is a set of machining instructions. Okay. It is a set of machining instructions written in a standard format for our numerically controlled and computer numerically controlled machines. So these instructions can be either punched on the tape using the tape punching machine or directly fed to the computer. I said this already. Okay. So what are the different types of part programming? Okay. So we need to fed it to the NC and CNC machines. So what are the different types of part programming? Based on the method of feeding the part programming to these NC and CNC machines, the part programming can be of two types. One is the manual part programming, and the second one is computer aided part programming. Okay, so you don't need to worry about your manual part programming, because we are not having any conventional NC or CNC machines right now. Okay, we have living in a modern era, and we have CNC machine, and we also have the computer aided part programming. So only you have to take care about the part that is computer aided part programming. Okay, so how they are written? Okay, we have some coordinate systems used in manual part programming. I already told you those are absolute system and incremental system. What is absolute system? In this one, the coordinates are mentioned in the program with respect to one reference point, one initial point. We can call it as datum. Okay, if you are representing any point on the object by using that reference point, then that system is called as absolute system. And the second one is incremental system. Incremental system, the coordinates of the points are mentioned in the program with respect to the previous point. Okay, precessive points. I am only considering the last point what I mentioned. If that is the system, that is called as the incremental system. I said about the part programming, that is manual part programming and computer aided part programming. So we have a specified standard format for writing the manual part programming, right? To write the manual part programming or a part programming, we have a standard format. Okay, you have to write the part programming in that format to process it into the machine language. Okay, so first you have to take care, or the first thing is block and word. Okay, first thing is block. You may ask me what is block. Okay, so this block is a group of words. Okay, group of words for feeding the NC and CNC machine systems to execute a particular movement of the tools. Okay, if I want to execute a particular movement of the tool, I need to feed my programming to the NC and CNC machines. Okay, and that is written in the form of blocks. Okay, and these block is a group of words. Only we have block and word, and block is a group of words. So now you may ask me, what is words? Okay, or a simple, what is word? In a simple sense, word is a group of coded instructions. Okay, so block is a group of coded instructions. Word is coded instruction. Block is a group of coded instruction. So each coded instruction in part programming is called as word. Okay, we have many types of coded instructions. Okay, and those coded instructions are called as word. Okay, you have seen here, you can see here, we have different words in a block. What are those? Well, the first one is the program number. Program number. What is program number? Well, this program number is actually a 4-digit number, follows the letter O in a programming number. If I writing a programming, I need to write the first initially the programming number. Okay. Well, the programming number is actually a 4-digit number which is going to be written after the letter O. Okay. So the programming number can be written in a manner that which allows the general programs, simple programs from O0000 to O7999. Simple or general programs are classified in the numbers from 0 to 7999 followed by the letter O. Okay. And if you are facing the custom macro programs, some quite complex programs, then those program numbers will come into the O8000 to O8999. Okay. Well, I said the programming number is a 4-digit number. So we can write it from 0 to 9999. General program takes till 7999. Okay. And macro programs take 8999. What about the left? 9000 to 999. Okay. Those are taken by the machine tool macro programs. If you are having some program which is based on the machine tool, then that will comes under O9000 to O9999. So it is a 4-digit number. What it indicates is it has 9999 different programs. Okay. So that is about the program number. First you have to write down the program number. Going for any programs, any operations, you have to write the first program number. Okay. Second comes is your sequence number. Okay. Sequence number which is indicated by the letter N. Okay. So the sequence number is also known as N code, is used to identify the block within the NC and CNC programs. I need to identify the sequence. I need to have a specified, a standard sequence for the operation. So that's why I'm going to use N codes. Okay. So the block can be searched in a program by the controller through the sequence number. So the sequence number is designed by a letter N followed by 3-digit number. Well, program number is 4-digit number followed by the letter O, but sequence number is the 3-digit number followed by the letter N. Okay, 3-digit in the sense we can write it down the sequence. We can have the sequence from 000 to 999. So in 999 sequences we can arrange our programs. Okay. Let's say for example N200. Okay, if I consider the N200, some control requires sequence number to be input in ascending order, some of the ascending orders, while other controllers allow any 3-digit number after the letter N. Okay, this is about sequence number. Next, very important codes are the preparatory functions. Well, the preparatory functions are indicated by the letter G and they are called as G codes. And it is also known as G codes, are used to prepare the controller for instructions that are to follow. Okay, I need to follow some instructions. Preparatory functions are actually the instruction to be followed. Let's say the letter G is followed by the 2-digit number. Okay, program number 4-digit, sequence number 3-digit, preparatory function 2-digit. 2-digit number prefixed by this letter G indicate a predefined function. Okay, well, I said preparatory function is a very important because it is going to have the predefined functions. For example, I have G00. Okay, G00 means, wait a minute, I said G00. Well, G00 is actually the function for rapid tool movement. If I want to move my tool from one position to another, I am going to use G00. Okay. If I consider G02, it is used for NC controller unit for circular interpolation. Okay, circular interpolation. So from 999 preparatory functions we are going to have. So next comes is your coordinate functions. Coordinate functions, in the sense, the coordinate functions design the position of the tool. Well, simple, right? X, Y, Z, or we can represent it with U, V, W and I, J, K. So if we have two axis systems, only two of the words would be used. For example, the tool tip, let's say I want to move my tool from 0, 0, 0 to some 100, 20, 100, then X 100, Y 20 and Z 100 I need to write down. So this is about coordinate functions. Next code is, or the format is, feed function, okay, which is represented by the letter small f, okay, or you can write it with the capital F also, no worries. So this function is used to specify the feed rate. Name itself indicate it's a feed function. Well, what is feed rate? Well, the letter F is followed by the feed rate in mm per minute, okay. Well, for example, if I have F100, which indicates the feed rate is 100 mm per minute. So once this feed rate is programmed in block, it remains in all the subsequent blocks, okay, till it is replaced by another feed rate value. You cannot change it, okay. So next comes is your spindle speed function. Spindle speed function, name itself indicates it's a spindle speed function and it is represented by the letter S. So this function specifies the spindle speed, and the letter S is followed by the spindle speed in revolution per minute, okay. So next format is tool function. Well, that is represented by the letter T, and this word is needed only for machines with a tool or the automatic tool changer. Well, you can see you have some VMC machines, vertical milling centers, okay. In those machines you have some automatic tool changers, okay. So in such machines you are going to use the tool function word, okay. It indicates which tool is to be used in the operation. Let's say I have an example. You are writing in the program T08, okay. What it indicates is we have a tool number 8 in the tool turret position of 8, okay. That is about the tool function. The finally is miscellaneous functions. Well, that is represented by the code M. Miscellaneous functions, also known as M codes, are used for indicating some miscellaneous functions. Like, what are miscellaneous functions? Like the extra works. Like say, I want to on my coolant, I want to off my coolant, I want to on my spindle and off it. Spindle counterclockwise or clockwise I wanted to rotate it, or I wanted to start the program what I fed just now to the machine. Then we are going to use the miscellaneous functions, okay. So this is about the formats or the standard formats for the part programming, okay. Well, you can see here the format for the manual part programming. We have any part program contains number of blocks. So this each block contains number of words, and the format is the method of writing the words in each block. Let's say I said first we have to use the sequence number. Before that we have to use the operation number, okay. Well, it is not mentioned here, no worries, okay. First we have to write down the operation number, then the sequence, then the preparatory function which is G, then coordinate functions, then feed function, that is feed function, then spindle speed we have to specify, tool function we have to specify. Then if we have any miscellaneous function needs to be added, we have to add it. Then we need to write down the EOB, that is the end of the block or the end of the program, okay. So this is about the format for writing the part programming. Well, let's see how to write down the manual part programming for turning operation, okay. Turning operation. Turning in the sense, in lathe or turning centers you have seen, we have a workpiece which is rotated and tools are stationary, okay. Well, these workpieces are mounted on the sliding turrets. You have known this one, right? So how to write down the manual part programming for turning operation? So before going to that, you have to follow some coordinate systems are used, okay. So you have some coordinate system, but only you have know that the coordinate systems x, y, z. Okay, you don't know the rotational axes, the secondary linear axes, or the incremental dimensions. So if you want to write down the part programming for turning operation, you must know what are the different coordinate systems used. So we have 4 types of coordinate systems. The first one is main axis, second is rotational axis, third is secondary linear axis, and fourth one is incremental dimensions in circular interpolation. So what are main axes? The nomenclature of 3 main axes, that is x, y, and z, is based on the right hand rule, right? Right hand rule involving the middle finger, index finger, and thumb of the right hand, where if you hold your hand like this, the right hand rule, as per the right hand rule, your thumb will indicates, or it is along the positive x direction, and your index finger is along the positive y direction, and your middle finger is along the positive z direction, as shown in the figure. Okay, so those are the main axes, x, y, and z. Next comes the rotational axes, and they are indicated with the letters A, B, and C. So designation of each rotational axis is based on the linear axis about which the rotation occurs. Okay, so when looking along a main axis in positive direction, clockwise rotation is positive. Well, let's say that I am looking along the positive x axis. Okay, positive x axis, and the clockwise direction is known as A. Clockwise rotation is known as A, positive A. If it is rotating counterclockwise, then that will be indicated negative A. Okay, so if I am looking along the positive y, the clockwise rotation will be positive B, and counterclockwise will be negative, and same for the C for Z axis. This is about rotational axis. So next comes is your secondary linear axis, and they are represented with the letter U, V, and W. While the other useful secondary linear axes are designed are U, V, and W. Now what are these secondary linear axes? Well, let's consider I have x, y, and z. Okay, those are represented with x, y, and z, nothing to do with. Okay, but I have a line which is actually parallel to x axis. Okay, so then that parallel axis is called as secondary linear axis, and if it is parallel to x axis, then it is indicated with the axis u. If I have a line parallel to y axis, then that is v, and if I have a line which is parallel to z axis, then that is indicated with a w, and those are called as secondary linear axes. So finally, we will coming for the incremental dimensions in circular interpolation. Okay, and they are represented with the letters I, J, and K. So I is used as incremental dimension is x axis during circular interpolation. Let's say I have a workpiece of 50 by 50 mm and I want to cut it at one side. Okay, so that is called as circular interpolation. If I incremented the dimension in x axis, that is taken as I, incremented the dimension in y, that is j, and incremented the dimension in z axis, then that is used as k. Okay, so this is about the coordinate systems used in manual part programming for turning operation. Okay, so next, before writing the part programming for turning operation, you have to consider some cutting process parameters. Okay, some cutting process parameters needs to be selected for turning operation. Well, the first one is the cutting speed. Cutting speed, which is indicated by the letter V. So what is cutting speed? This is a cutting speed of a tool is the speed at which the metal is removed by the tool from the workpiece. Okay, it is the speed at which the metal is removed by the tool from the workpiece. Well, the speed at which it is removed, in the sense we are removing the material by considering the time. Okay. So in a lathe machine, you have seen it is a peripheral speed of the workpiece and is given by the letter V equal to pi dn by 1000. Okay, pi dn by 1000, which is in the unit meters per minute. Meters per minute. Where d is the diameter of the workpiece and n is the spindle speed, which is in revolution per meter. Let's say that revolution per minute. Okay, let's say that I have a cutting speed of 10 meters per like 10 mm per minute. Okay, what it means? It means I have a tool, I have a workpiece, and I am cutting 10 mm of the material, 10 mm of the material, or removing the 10 mm of the material from the workpiece in a minute. Okay, this is about the cutting speed. Next is your feed or feed rate. So what is feed? The feed of a cutting tool in a lathe is the distance the cutting tool cuts for each revolution of the spindle and workpiece. Each revolution of the spindle. Feed in a simple sense, if I have 10 revolutions of the workpiece and how much material I am cutting. Okay, so the feed in mm per revolution and the feed in mm per minute are related by the equation F is equal to N into F revolution. Okay, where N is the spindle and workpiece speed in revolution per minute and F revolution is feed in mm per revolution and Fm is the feed in mm per minute. Okay. So the only thing you have to take care is if you increase the feed, which reduces the cutting time. If you are going to increase the feed, it is going to reduce the cutting time. However, increased speed is going to reduce the cutting tool life also. Okay. So next cutting process parameter is the depth of cut. Depth of cut, which is indicated by the letter T, is the perpendicular distance which is measured from the machined surface to the uncut surface of the workpiece. Okay, while you are cutting the material from your workpiece, okay, just you have to consider the distance at which or the perpendicular distance measured from the machine surfaces. Okay, so the depth of cut is measured by the formula T equal to d1 by d2 by 2, where d1 is the diameter of the workpiece surface before machining, which is in mm, and d2 is the diameter of the workpiece surface after machining. Okay, so this is about depth of cut. Well, let's move to something very quite important. I already said we have preparatory functions. Those are G codes in the turning operation, and they are quite very important. Okay, they are quite very important. Let's see some of them. Let's see only some of them. Okay, so the first one, so what I said, G codes are written with G00. Okay, the first one is Z00, which indicates the rapid tool movement. So this G00 is the positioning function and used for rapid movement of the tool to the specified position. So using this word G00, the cutting tool can be positioned near the cutting surface in a very shortest possible time. So how I need to write down the program by using the rapid tool movement. So I said first we have to use the operational code. Well, it is not used here, no worries. Then you have to use the sequence number. Okay, sequence number, then the preparatory function, then the coordinate point, then end of the program. Okay, so let's say we have a simple one here. The first we have written N100, that is actually the sequence number. Sequence number of the rapid tool movement is 100th. Okay, then I wanted to move my tool from one position to another position. That is just simple movement. Okay, so I am using the preparatory function G00. Then I wanted to move my tool from x0 and y0 to x25 and y35. So I need to write down this program to have the rapid tool movement from gx00 to x25 and y00 to y35. So this is about the rapid tool movement. Next code is your G01. which indicates the linear interpolation. Linear interpolation. What is linear interpolation? In a simple sense, the cutting of the material. Okay, cutting of the material. So G01 is the function for the motion of a cutting tool along a straight line from a current position to a given final position at a given feed rate. Okay, why we are giving the feed rate? Because it is cutting the material. Okay, but in the rapid tool movement we are not giving any feed rate because it is not cutting the material, it's just moving from one position to another position. So this is the function for linear interpolation. First we have to write down the sequence number, then the program, then the preparatory function, that is G code, then the final position of the cutting tool, then the feed rate. So as per here it is written N110. So 110th is my sequence of this operation. Then G01 indicates the linear interpolation from initial position to X40 and Y45 are the final cutting positions. Okay, then the feed rate of F120, which means 120 mm per minute it is going to cut the material. This is about G01. Next comes is your G02, which indicates the clockwise circular interpolation. Okay, clockwise circular interpolation. Well, the name itself indicates G02 is a function for circular interpolation in clockwise direction. It is the function which direct the tool along the circular path in clockwise direction at a given feed rate. But only it is important to note that the cutter must be at the start of the arc. That is the point as per you are seeing here in the workpiece. It should be at the start of the cutting position. Okay. Well, we are seeing here we have a workpiece which is having 50 and 50 of dimensions, and I wanted to have the circular interpolation, or I wanted to cut one side of the workpiece with a radius of 25 mm. Okay, I wanted to have the arc. Okay, that is the circular interpolation. Okay, so we can write down the program, the circular interpolation, by using two methods. One is arc vector method and second one is arc radius method. So what is arc vector method? In this method, the arc can be generated by knowing the coordinates of the endpoints and the center of the arc. Knowing the coordinates of the endpoints and the center of the arc. Okay. So if I want to have an arc by using the arc vector method, I must input the coordinates of the endpoint and the center of the arc. Okay. So before starting the program, what the thing we have to take care is my cutter should be at the starting position. So it is a clockwise circular interpolation. So my cutter should be at the position of A. Okay. Put the position of A. Here it is written. Okay. So first I need to write down the sequence number. Then circular interpolation, that is clockwise. So I am going to use it as G02. Okay. Here you have to take care is we have to write down the coordinates of the endpoints of the center of the endpoint. Okay. Endpoints of this arc is actually the point B. Okay. The endpoint of the arc is point B. So B is actually, if you consider the original point, that is X0 and Y0, the point B is actually 50 mm and 25 mm away from the origin in X and Y axis, but it is using, they are using X70 and Y25. That is not the right thing. Okay, we have to mention the endpoints, that is X50 and Y25. Then we have to enter, as per the arc vector method, the center of the arc. Well, the center of the arc is X, center of the arc is 25 and 25. So these are the secondary coordinate points which are indicated by I, J and K. Okay, so we are dealing with only two-dimensional objects here, so we have to use I25 and J25. Well, they are using I45 and J25. That is not right. I25 and J25 along with the feed rate. Well, the feed rate here given is 150 mm per minute. So this is how we have to write down the program by arc vector method. Well, the another method is arc radius method. Well, here everything is same as the arc can be generated by knowing the coordinates of the endpoint, but here the change is we have to write down the radius of the arc instead of the center of the arc. Radius of the arc instead of the center of the arc. So only we have to change is radius of the arc. You can see here n, the sequence 1, then the circular interpolation, then the endpoint x50 and y25, and the radius r25 with the feed rate. This is how we have to write down the part programming by using the arc radius method. Okay, so fourth one is your counter clockwise circular interpolation, G03 actually. Okay, well, that is not sorry, I haven't changed it, I changed it to Z04. That is not 04, that is G03. Okay, G03 is the counterclockwise circular interpolation. Same here, as it is circular interpolation or the counterclockwise circular interpolation, we have to take care. My tool tip is at the initial position, that is the point A. Here you can see here we have a different figure. Okay, my position, the initial position of the tool must be at the initial point, that is A. Okay, so by arc vector method, what I needs to consider, what are the things I need to write down? The final position and the center of the arc. So the first sequence N130, whatever the sequence it is, we can write anything, and then the G code, that is G03 for counterclockwise circular interpolation, then the final point of the or the end point of the arc, that is x25 and y50, and the center of the arc is I25 and J25 with the feed rate of 150. Okay, 150 mm per minute. So that is by arc vector method. Then if I am writing the same thing by arc radius method, I need to specify the end point of the arc, along with I need to specify the radius of the arc. So N130 is the sequence, then G03 is the counterclockwise circular interpolation, x25 and y25 is the final position, where r25 is the radius, and with the feed rate of 150 mm per minute. So guys, this is about your preparatory functions, simple preparatory functions. Okay, so I think you all are understand. In next video lecture, I am going to start some important G codes and their function. What are the G codes and their functions, and what are the miscellaneous functions used in the turning operation. Okay, thank you very much. Have a great day. Okay, bye guys.